Ask me about that another time. Okay, so we are live. So we're going to, and by the way, feel free to ask questions, even though we're recording to YouTube. That's totally fine. It'll just make it a better lesson. So we're going to make our first processing sketch. The first thing I want to tell you about is comments, because you probably want to write notes to yourself, like to remind yourself, especially when you're learning, what these things do that you type into the program. Also, there's going to be things you're going to want to write notes to me, like what's your name when you hand something in, or what date did you write this software. And you can also leave notes to yourself, like what are the things that you need to do next class? What features have you implemented? What haven't you implemented? So this is all really good. Thanks for your question. Oh yeah, if you want to borrow a piece of paper and write some notes, feel free to, you can take it. I got some lined paper under here if you'd like. It's giant, but I don't know, whatever you think is better. Yeah, feel free if you'd like to write notes. That's okay. I'm going to be typing in here, and I'm going to, whenever I have a comment to make, I'll also show you how to make a computer comment so that the computer ignores it. So the way to do that is put 2 forward slashes. It's the same key as the question mark. And if you put 2 slashes, then anything else you type on that line will be ignored by the computer. So you could put in things like your name or the date. You could say first program, and then September 12th or something like that, 2016. And you can put your name. I'll put my name. And generally, when you have something you're going to hand in, you'll put your name at the top as a comment. You can put these comments at the end of a line as well. So you could type a line of code and then put a comment at the end to explain what it does. Because maybe you won't remember next class. So this is also my way of giving you guys notes. I'll just type programs and we'll add notes in the sides and the top. That will be the comments. And this will be a completely running program. Okay, so that's what comments are. Next thing, we're going to see a little bit about how processing works. So as you probably figured out, this is where you type your program. And when you want to run your program, you can just press the little play button at the top. So if I run this program, it really doesn't do a whole lot. A little window pops up though. This little window is going to be where your program lives. So if you write a game, if you write make a picture in processing, it'll be in that little window. So that's the first thing we're going to learn about is how do you control that window. So that window automatically comes up, but you can control its size. And the way you do that is by typing in the word size. Size. Now, there's going to be a whole bunch of commands we're going to learn in the next little while, and they all follow the same format. So I'm not going to get into it too deep until we have a couple of commands that we've written out, and then I'll show you kind of what the pattern is. But you need to be able to tell it what size. So we say the word size, and it's like telling the computer, hey, we're setting the size of our window. So the way processing works, and by the way, this is the same as Java because processing is written in Java. You put a parenthesis, and then you type in 2 numbers. I'm going to type in 600. I'll do 640, 480. I'll use the scratch dimensions of the screen in case you took scratch. And then I end it with a semicolon. So we'll talk a bit about the pattern of how these things work. But if I run this, you'll see that the window's bigger. It's I put 650 apparently. I didn't mean to, but that's fine. 650 pixels wide and 480 pixels tall. So that's what this does. And I'm going to put a little comment. I'm going to press the 2 slashes. I recommend doing this as well for you. And I'm just going to say what this does. Creates a window, and I'll keep 650. That doesn't really matter. 650 pixels wide, 480 pixels tall. So in processing and Java and a lot of programming languages, the way that you make something happen is you give it a word like size, and then you give it additional information in the parentheses, and each number that you give it has a predefined meaning. So always in size, the first number means the width, and the second number means the height. And then the semicolon comes. The semicolon tells processing that you're finished, you're done this command. And if you forget the semicolon, it doesn't know what you're doing. So if I delete the semicolon, check out what happens. I'm going to run it, going to press the play button. Oh, look at that. It says, it gives a weird error message. It highlights this line and says there's something wrong with it. Check out down here. This is a little message window that processing uses to talk to you. I'll zoom in so you can see. Unexpected token, null. Now, some of the error messages that you're going to get don't really make a lot of sense. But it does definitely highlight this line. And putting semicolons at the end of every line is just going to come second nature to you. Oops. Just like putting a period at the end of a sentence. It was probably kind of weird when you first learned it in grade 1, but now it's so easy to do. So lines end in semicolons, and we have a list of numbers that we give any particular command to specialize that command. So that's great. So every little command we're going to learn is going to follow this pattern. And I'm going to use the official terminology for the commands. The official terminology is functions. So commands are called functions. And the way they always work is this is going to be a little comment I'm going to put. I'm going to say this is the general form of a function. It goes, you give it whatever the function name is. And by the way, it's case sensitive. So if you tapped capital S size, it wouldn't work. If you put a capital Z or all caps S-I-Z-E, it doesn't know what you're talking about. So it actually has to be exactly whatever capitalization you give it. So you give it whatever the name of the function is, and then there you give it a parenthesis, and you just give it a whole bunch of numbers. And each different function has different list of numbers that it's expecting. They're called parameters. Oops. So you give it parameter 1, and then a comma, and parameter 2, and a comma. And there might be a whole bunch of parameters, or there might be no parameters. Depends on the function that we're learning. And then you end it with a semicolon. And that's how all the functions are going to look in processing. All the little commands. And for the first few classes, just learning what their names are and what the numbers are and what order they go in is going to feel like a lot of learning to do. But like I said, it's going to become second nature as we go. That's the general form of the function. So let's do another function. Are you guys ready for a whole new function? Let's do it. We're going to do background. So background, what it does is it sets the color of the background. And it's not the whole story, but we're going to leave it at that. So what kind of number can you give it to represent a color? Well, we'll start with just shades of black and white. So if I give it a 0, that's black. And if I give it a 255, that's white. And if we run it, like if I set it to 0, and I run it, you'll see that my window's black now. And if I put in 255, it's white. And if I put in 100, what do you think you'll see? Gray, that's right. So there's not 50 shades of gray, folks. There is 256 shades of gray. From 0 to, I know, slow clap, it commences. So 0 is, I'm going to make a little comment here. 0 is black, 255 is white, and everything in between is a shade of gray. Why don't we just work in shades of gray for a little bit, and we'll come back and talk about how we can make it color. So pick your favorite shade of gray. I'm going to choose 150. I don't know. I'm not sure what that is, but I'll just go with that number there. So that covers the screen in a big pile of gray. Just covers in gray. All right. So next thing we're going to learn is how do we draw shapes to the screen. So I'm going to show you some of the commands for drawing different kind of shapes. After that, I'll show you how we can control the coloring of those shapes. We'll just do black and white for now, but pretty soon I'll show you color. So, what do you guys want to learn? You want to learn rectangles, ellipses? We'll just do one of those two. Rectangles or ellipses? What do you want? Ellipses? Okay, we're going to do ellipses. Can you guess the function name for making an ellipse? Ellipse! Whoa. Holy cow, you guys are doing great. It's too complicated. Now, spelling ellipse is hard. I always screw it up, but it's 2 L's. Ellipse. Now, you can make circles with ellipse, by the way. You just got to make sure the numbers match up. So you can type in ellipse, and now what comes next? What punctuation mark will come next? Parenthesis, yeah, you're going to put in a parenthesis. You can put a space here or not, by the way. I tend not to, but whatever. You guys can do whatever you like. And then there's going to be some numbers that come in here. So what do you think you need to describe an ellipse? What are some, like a circle? What kind of information are you going to probably need? Yeah, thanks.
Minor axis and major axis.
Yeah, like its position on the screen. So we're going to need coordinates. And what else it makes an ellipse different from other ellipses?
How big it is.
Yeah, how big it is. You bet. And we're going to specify how wide and how tall it is. That's how we're going to be interacting with ellipses. So actually, I'll just make a comment before I type it all in. The way ellipses work is you type in ellipse, and then you give it an x and a y coordinate. And remember, our screen is 650 pixels wide and 408 pixels tall, so you have that sort of space to work in. And then you give it a width and a height. So that will be how wide it is and how tall it is. You probably could have figured that out. And then, of course, semicolon. So we're going to give it 4 numbers. The first number is the x coordinate. The second number is the y coordinate. Third is the width. Fourth is the height. And it's always just going to be that way when you make an ellipse. So I'm going to type in some numbers, and we're going to be like, why is math wrong? So let me type in some stuff. I'm going to type in 0, 0. So it's x and y coordinate is at the origin. And then I'm going to type in a width of, let's say, 200 and a height of 200. That should be a circle because its width and height are the same. So it'll make a circle. How do you guys feel about that? That makes sense? Yeah? Cool. So I'm going to run that. Let's see what happened. So I made a circle, but weirdly enough, it's up at the top left corner. So what's up with that? We said 0, 0. So it turns out in processing, the origin of the XY coordinate system is not the center of the screen. And even weirder, check this out. Which of these numbers is the Y coordinate? First, second, third, or fourth? Second, right? In math, when you make the Y coordinate larger, does the point move up or down?
Up.
In math, it moves up, right? If I was graphing something and its y coordinate was 100, it'd be way at the top. If it was negative 100, it'd be way at the bottom. It's upside down in processing. So if I type in, well, let's type in like 300 to make it somewhat dramatic. It's actually going to go down. It's going to be down here now. If I type in, we can't see too much if I type in negative numbers. If I type in negative 50, it'll like move up. So that's backwards. I'm going to show you a quick picture of what's going on here so you can see it. So on the website, first look at processing, I have this picture that kind of explains what's going on. So this is the XY coordinate system. I should gesture with the mouse because people on YouTube can't see me touching the screen. So here we go. So this is how math usually works, right? X-axis, Y-axis, origin at the center. As you go up, numbers get bigger. So over on the right, that's how computers track coordinates on the screen. And this is not just because of processing. All computers use this exact same system. And the reason is because adding in a negative number is just extra work for a computer. So if we do it this way, if we make the y-axis upside down, so that we actually go down as we count up, and if we make the origin the top left corner, there's no negative numbers needed for keeping track of coordinates. So that's the reason. It goes back to when we had really ancient monitors and really bad computers where we couldn't afford the one bit to keep track of whether the number is positive or negative. Our computers now can handle it, like this system over here, but everything is sort of left over from the 1970s when computer monitors were becoming a thing. And we've all just continued it on. So you guys are going to have to get used to this. It's going to be hard and frustrating at first. You're going to be like, where do I put this thing? But we're going to have that robot drawing assignment where you're going to have to position things all around the screen, and it'll really help you get used to the coordinate system and processing. It's probably going to be the most annoying thing throughout the course. You'll always forget. You'll make something move up in an animation, it'll move down. You'll be like, oh yeah, y-axis. It'll keep coming back to haunt you. But by the end of the year, you'll be a pro. The one thing I fear is in math class, you'll end up doing it upside down or something. So you have to just like remember how it actually works in regular math. Oop, I keep pressing save by accident. I have a, I don't know what the word is, just a habit of pressing save all the time. Let's save it right now. Let's save it. I'm going to go File and save as. Oops, I failed. I misclicked. Let's try again. File, save as. And the default place is going to be what's called your sketchbook folder. It's a good place to save things. So just save it in the default place because it's in your My Documents folder, and wherever you go in this classroom or in the Vancouver School Board, to be honest, you log in, you'll have this with you. So it's good to have. I'm going to make a new folder for myself called Beginning Programming. And I'm going to call it Block 2C because I have 2 blocks of programming. And I want to keep my stuff separate. And I'm going to name this, instead of sketch underscore 1609112A, that's a pretty bad name for a sketch. I'm going to call it first program. Technically, the programs are called sketches in processes. So I'm going to call it first sketch. And technically, it'll replace the spaces for me. You can do that. I'll save it as first sketch. So go ahead and do that. Is anybody having trouble saving stuff? Yeah.
So we save it in processing?
Yep. If the folder says processing, that's the right place to save it. It's just the default location when you go to click Save As. And make your own folder in that folder to organize stuff if you want to. Okay. So here's a skill testing question for everybody. Once you've saved it, here we go. Think about this. You don't have to answer out loud, but I want everyone to think about it. And don't answer out loud, just everyone have a chance to think about this. What XY coordinates should I give it, given how the origin works and how the upside down y-axis works? What coordinates should I give it to put it in the center of the screen, this ellipse? So just give everyone a chance to think about it. Don't say it out loud. And go for it. Thank you. Yeah, you basically just divide the width and height by 2. So it's 325 and 240. If I run that, I'll get a circle there. Awesome. Okay. So, go ahead and catch up if you haven't gotten that working yet. I'm going to put a rectangle in next. So get ready for rectangles. So amazing. Yes, thanks for your question.
Why is this like text error?
Oh, okay. So you guys, when you run your programs, you might get an error. Give me 1 sec. I'll come on over and take a look. We'll let the YouTube run. Oh, it's because actually there. It's where you're missing your semicolon. Put in a semicolon. Should be good. Yep. Don't worry, folks. You're going to forget semicolons all over the place. Eventually, it'll become a habit, and you'll be good. Okay, so I'm going to move on now. Do some rectangles. Let's make our circle a little bit bigger. I'm going to crank it up to be 400 by 400, just to give myself some room. Let's just run that and see. Looks good. There we go. Nice big ellipse. So that's what I got my numbers at. And you should definitely start getting used to, if I change this number here or that number there, what's going to happen? Being able to predict that as we go forward. Okay, so next is rectangles. What do you think the command for rectangle is going to be? Not delete system 32, and it's not rectangle either. Processing. Why weren't you consistent? It's rect, which will lead to all sorts of jokes about get wrecked and all sorts of things like that. So, please feel free to make those jokes. They're all very funny. So what do you need to do for a rectangle? Actually, same thing. You need to give it an X and Y location, and you need to give it a width and height. So it's going to be a little bit different, though, because the X and Y location isn't the center. It's going to be the top left-hand corner of the rectangle. And I apologize for that in advance, because that's a little bit unintuitive. So you're going to give it, here, I'll do the same comment I did before. I'll do rect. It's going to be X and Y, or the first and second numbers, and then width and height again. Height is hard to spell. And then I'll just note X, Y is the, didn't need to put a slash there, did I? X, Y is location of top left corner. Just going to put that in there. So that's the pattern of how rect works. You tell it where the top left corner is, and you give it a width and height. So let's try and get that rectangle inside of the ellipse. So we're not going to make it perfect. We're just going to get it in there. Feel free to figure out the exact coordinates to like center it and all that kind of stuff, but I'm just going to plunk it in there. Let's try, I don't know, 200, 200. And I'm going to make it 100 wide and 100 wide. Make it a nice square. But you guys can try whatever you think. Okay, I'm going to run that and see. Oh, there it is. It's not centered at all, but that's okay. So I got it inside. The reason I wanted to get it inside is because I wanted to show you what happens if you change the order of things. So the order of you typing things into processing matters a lot. Basically, processing starts at the top, and it does that thing at the top. If it's a comment, it ignores it. So first thing it does is it makes a window. Then the next thing it does is it draws a background. Then it draws an ellipse, and then it draws a rectangle. If you change the order, it will change the order in which it draws things. So check this out. If I was to put my rectangle before the ellipse, watch what happens. You don't have to do this, by the way. Just watch and notice what happens. So now I have background, rectangle, ellipse. If I run it, there's no rectangle. So what happened there? Where is the rectangle? Behind the ellipse. That's right, behind the circle. So there's no way to get at it. It's not like Photoshop where you have different layers and you can peel it back and look at the layers. It's just eclipsed completely by the ellipse. It's just absorbed into the ellipse. It's gone. And guess what? If I put background first, background last, well, it's as if I didn't do anything. It's just the background is the last thing that gets drawn. So the order of things matters quite a bit. And you're going to get a lot of practice on that. When you go to draw this picture here, you're going to have to draw the sky, and then the sun, and then the mountains, and then the robot, and then the eye, and so on. You have to get things sort of ordered in the correct order. So that's going to be something just to keep in mind as you're working on your processing project. If you wanted the sun ahead of the mountains, then you would write the code for the sun lower on the screen than the mountains. Does that make sense, folks? How you get things behind and in front of things? Yeah? Great. If it doesn't make sense, don't worry. This assignment will make it make sense as you go through it. So I'm going to reorder it again. I'm going to put it back the way it was. Hopefully you guys didn't change the order. How? And I'll paste it in. Okay, so rect, ellipse, those are great commands. Now, I could sit here and go through every single shape command, but I'm not going to. I'm going to instead point you to where you can find out other shape commands. And you guys can read about it and bring them into your project. So it's going to be something I want you guys to do. I'm not going to show you how to draw a line or a triangle, but I'm going to show you where to find that information. Don't worry, if you're having trouble doing it, I'll help you out. But I'll give you the chance to look it up yourselves first. So if you are trying to figure out what other things processing can do, check it out. You can go to the Help menu, and you can go to Reference. You guys see that? I'll zoom in. Help, Reference. It's also available online. This technically is offline, even though it's a website. And you can scroll down and check it out. 2D primitives. Oh, I think I clicked on something by accident. I don't know what I did. But here we are. 2D primitives. Right here. These are all the shape drawing things. And look, it's got, oops, a triangle I didn't mean to click on. It's got ellipse, we just did. It's got rect. It's got a bunch of other things too, like line and triangle. Those we're going to use as well. And to learn about how they work, you can just click on, say, line, for example. And it shows you examples and tells you can do things that we're going to learn about in a second. And you can see all sorts of examples of that working. It tells you all about it if you like to read paragraphs about how things work. And it also has the same kind of notes that we have. So for example, for a line, you give it an x and y coordinate for one point, and then an x and y coordinate for the other point, and it connects the lines, or it connects the points, and makes a line. So instead of sitting here and wasting your time just telling you that, I'll let you look those things up and ask questions if it doesn't make sense. Because I think for a lot of you, you can just figure it out from here. So again, one more time, whoops. How you get there is help, and then reference. So that works out nicely. And it also has the entire processing language on that web page as well. So if you're trying to get ahead and do new things, If you want to find out how to do 3D graphics and, I don't know, video editing and all sorts of crazy stuff, you can get a head start by going there and poking around and seeing what's going on. Okay, so next thing I want to do is tell you about colors. Because colors, you know, black and white's nice, but we want colors. Also, how do we affect the colors of the shapes? How do we make the outline color different from the inside color, and so on? So let's talk about what colors look like in processing, and generally in computers. If we give one number when it's expecting a color, it'll default to a shade of gray. But if we give it 3 numbers, we'll be able to control the red, green, and blue aspect of a color. And it's in that order. So I'm going to rewrite this command, this background function. So actually, I'll comment out the old one. I'll just put the double slash there, and it'll just become a comment. It'll be ignored. And instead, I'll make a brand new one, background, and I'll give it 3 numbers. So the first number is the amount of red. Let's give it 200 red. It's between 0 and 255 again. So that's how much red. I'm going to give it 100 green and 45 blue. So I'll just make a comment to indicate that it's red, green, and blue. And each one is 0 to 255. So what color has, 200 red, 100 green, and 45 blue? I have no idea, actually. Let's run it and find out. Orange, kind of browny orange, apparently has those colors there. So that's how you can control it. You can get any color by mixing different amounts of red, green, and blue. Now, you don't have to use trial and error. You don't have to just keep guessing over and over again. Processing is a built-in tool that will show you, what colors do what. So under Tools, there is a color selector tool. So you can click and say I want like a nice steel blue color. Awesome, there you go, that color there. Well, it tells you in the middle 3 here, it says I need 3 red, 177 green, and 255 blue. Notice it also has other things. HSB, it has this hashtag code thing. There's actually other ways to work in color and processing, but we're not going to learn that today because you're learning enough new things at the same time. But just be aware that there's other possibilities. So I'm just going to type in 3, 177, and 255. And I challenge you guys to pick a color right now. Pick your own color that you like and choose it. So I'm going to do 3, 177, and 255. And voila! I got my bright blue that I like so much. Okay. So I'm going to go on to the next thing. So if you haven't picked a color, just give it up and try it again later for the colors. Now, the next question is, how do I affect the colors of my shapes? Background has a place to put in the color information, but where do I put in the color information for ellipse or for rect? So that's 2 new functions to learn. They're called fill and stroke. So fill changes the inside color of things. Stroke changes the outline color. And there's something called stroke weight as well, which changes the thickness of lines. So let me do that right now. I'm going to type out those 3 functions. I'm going to type out fill. The same thing works as it does for background. You can type 1 number for a shade of gray, or 3 numbers for red, green, blue to get some color in there. I'm going to make it a green outline, I guess. So I'll say 0, 255. Oops, I pressed something. 255, 0. Sorry, so I'll make that a green inside color. And then that will change the inside color of things. I'm going to say stroke to change the outline color. And I'll make that red. This is going to be really ugly. Red and green at full tilt. 255, 0, 0. And then let's increase the stroke weight just to see what it does. Stroke weight. Stroke weight is just how many pixels wide do you want your outlines. So let's make it 20. Nice and fat. And I'll make a note because it's a little bit different. We'll do stroke weight and then thickness. That's how many pixels thick our lines will be. So if I run this, we'll get a gorgeous image. We have red strokes because the stroke is set to have maximum red and no green and no blue. And then the inside colors are green because we've set the fill to be all green. But you can change those numbers to be whatever you want. Now, carefully note that when you type in fill, stroke, and stroke weight, everything afterwards gets affected. So it's like setting up your drawing tools, and you're saying from now on, I'm going to have green shapes with red outlines that are 20 pixels thick. So if you wanted your rectangle to be different, then you'd have to do fill, stroke, and stroke weight again. Or change whichever one you want to change. So if I want the rectangle to be different, maybe I want the rectangle to be black and white. I'll say fill with black, stroke with white, and I'll make stroke weight of 10 pixels. And that will affect everything after it. The only thing that's after it is a rectangle, so that's not a big deal. So these fill and stroke weight commands affect everything that comes after it until something new comes along to change its mind. So if I run that, I get different color shapes. A little bit clunky, right? But as you'll see as we go on, it turns out it's done for a reason, and it will later on make our lives much easier. So we have fill, stroke, and stroke weight, fill, stroke, and stroke weight. Chances are you're not going to have to change stroke weight that often, so it's not something that always has to be changed. But I just wanted to demonstrate that that's how it works. How do you guys feel about that? Is this making sense so far? Yeah? Pretty good? Now, technically, you have learned everything you need to know to make this picture happen. So just looking at this, what are some things that you're not sure that you know yet? Is there anything here you're like, how would I do this? Anybody want to throw out a comment of like, we're not sure how to do this or that? Thanks, Malcolm. Triangles, yeah. So how does a triangle work? So go to the reference page, and mostly I just want you to get some practice looking at the reference page. So go to the reference page and check it out. And notice that these are actually two different triangles. You could do I forget what it's called, a polygon or something, to make that sort of M shape in one command, but you don't need to. You can just make two triangles. And the reason why they look like they're one shape is because the stroke and the fill are the same. So when they overlap, you don't see the two triangles as separate. Their colors just blend together. So you can make the stroke color the same as the fill color. And to be honest, I think almost always that's true in this picture. I think always the stroke and stroke and fill are always the same, no matter what happens here. That's why you don't see any outlines around things. Anything else you're looking at here and it doesn't quite make sense? Thanks, Cole.
How do you rotate objects?
Oh, nothing's been rotated, although you can rotate objects.
I mean, like the tilting it, those lines are tilted.
Yeah, so if we're lines, you're talking about like the antenna thing sticking on the robot's head. So you specify sort of the 2 points of the lines. So you can specify, say, this point here. So you give an X and Y for that point, and an X and Y for that point, and then it draws a diagonal line. By the way, just so you know, you don't have to make this drawing like to the pixel exact. This is just sort of a rough, like, make a robot in front of some mountains and some sun, and make a green ground. You don't have to get the colors exact. You don't have to get the robot quite exactly looking like that. Just roughly estimate it. So have an antenna sticking out of its head, but you don't have to get it exactly at that angle or whatever. Like, I'm not going to be really picky about it. My purpose for making this assignment is not for you to replicate this. It's for you to get experience in this environment, both typing things down, learning the commands, and getting used to the coordinate system. So it doesn't have to be exact pixel perfect. So that's going to be fine. So thanks for that observation, though. It can be approximate. Anything else that just at a glance you're not sure how to do? I know in the past students have asked me about, how do I do semicircles, Mr. Pelche? You don't have to do a semicircle. How could you get around that? Yeah! Awesome! You could just draw a circle first, and then draw the robot body on top. Ah, smart, right? Same with the sun. People are like, how do you draw a Pac-Man shape? I need to make the sun, like, cut out. No, just draw the sun first, and then the mountain on top of it, and it will cover it up. Yeah? Make sense? Awesome. So that's what we're going to be doing starting next class. We have about, I don't know, what is it, 10 minutes left in class? So you're welcome to get started on this project. Also, it'll be a chance for you just to ask some questions. But we're going to have all of next class to continue working on this, and hopefully it goes smoothly for you. So if you want, you can get started on that. So I'm going to stop the video.